to fix fragile, slow, and non-deterministic integration tests, in scaling microservices, you must virtualize your network and message layers. You can achieve this boundary isolation by using WireMock. While historically known for REST virtualization, WireMock has evolved into a multi-protocol ecosystem. Through modular extensions and native updates, it supports mocking gRPC protocol buffers, GraphQL schemas, and WebSockets alongside standard HTTP endpoints. For asynchronous architectures, WireMock integrates with message brokers like Kafka, RabbitMQ, and Amazon SQS, allowing you to mock asynchronous event streams and event-driven data flows within a single, unified framework. Consider an isolated integration test, where your test runner triggers WireMock via a standard HTTP call. WireMock instantly fires an outbound payload to an open-source Kafka REST proxy, publishing a live event onto a Kafka topic. Your target microservice consumes this event from the topic, executes its internal business logic, and publishes a reactive response event onto an outbound Kafka topic. An open-source HTTP sync connector reads this response event and posts it directly back to WireMock's verification API. Your automated test runner then queries WireMock synchronously to validate that the complete event lifecycle passed successfully. Just remember, to achieve Kafka integration, you need three containers: Kafka Broker, Kafka REST Proxy, and Kafka Connect HTTP Sync. At the component and integration level, WireMock should never be deployed as a static, shared server. That is an architectural anti-pattern. Instead, spin up WireMock ephemerally. As you scale across multiple engineering teams, the biggest challenge becomes mock management. Should you use a centralized mock server, or should every team maintain their own? A centralized mock server becomes a bottleneck and a single point of failure. The architectural best practice is strict, decentralized ownership. Mocks must live alongside the source code. Teams should define their WireMock mappings in version control as JSON files. To eliminate the manual overhead of creating these files, your pipeline can automatically scan repository source code, identify controller endpoints, or schema definitions. If your service depends on three different teams, do you need to spin up three separate WireMock container images? Technically, you can run three individual WireMock instances on different ports or subdomains. This approach is acceptable because container overhead is minimal and it guarantees total isolation for each team's schema. However, there is a cleaner, more aggregated approach. Each upstream team can publish their versioned mock mappings as a simple, lightweight data artifact to a shared repository like Nexus, Artifactory, or an S3 bucket. During your PR pipeline initialization, your setup script pulls these three separate packages, combines them into a single local directory, and mounts that folder into one single base WireMock container instance. One server, unified multi-protocol mappings, zero architectural overhead. Regardless of your container topology, this decentralized approach introduces the most dangerous challenge of virtualization: contract drift. If an upstream team changes their real production schema but forgets to update their published mock mappings, your tests will pass in the pipeline but fail in production. To prevent this, WireMock must be paired with consumer-driven contract testing. Finally, utilize WireMock for chaos engineering. Do not just mock successful network responses or clean event payloads. Program your stubs to simulate broken gRPC status codes, connection resets, payload delivery timeouts, and artificial Kafka latency. This is the way to validate your circuit breakers, dead letter queues, and retry logic before hitting production. To summarize, deploy WireMock ephemerally per PR for your integration tests. Leverage its multi-protocol power for REST, gRPC, GraphQL, and Kafka loops. Use code agents to automatically generate your mappings, unify multiple team stubs inside a single container instance, prevent contract drift, and inject faults to test resilience. Thank you for watching. If you found this breakdown valuable, please subscribe to the channel and leave a like. See you.